When an engine runs correctly, everything depends on precise timing, from fuel injection to ignition. The ECU can only control the engine accurately if it knows exactly where the crankshaft is, how fast it's spinning, and when each piston reaches top dead center. All of that information comes from a single component, the crankshaft position sensor. When this sensor signal becomes weak, inconsistent, or drops out, the ECU loses reliable timing reference. That's when symptoms like hard starting, stalling, rough idle, hesitation, or trouble codes such as P0335 or P0340 begin to appear. In this video, we're not just listing symptoms or replacing parts. We'll walk through a proper diagnostic process, step by step, to confirm whether the ECU is actually receiving a usable crankshaft signal. You'll learn how to interpret fault codes, verify RPM input during cranking, inspect wiring and connectors, and test the sensor's signal with a multimeter or oscilloscope. By the end, you'll know whether the problem is the sensor itself, connectors, or signal loss. Number 1. Check engine light. One of the earliest and most visible warning signs is an illuminated check engine light. In many cases, the engine may still run normally, but the warning light tells you the ECU has already detected a problem. When the crankshaft position sensor signal becomes erratic or drops out, the ECU can no longer accurately track crank angle or engine speed. As a result, it stores timing-related trouble codes. The most common is P0335, indicating a crankshaft position sensor circuit issue. In some cases, you may also see P0340, which appears when synchronization between the crankshaft and camshaft signals is lost. These codes don't confirm a failed sensor yet, but they indicate that the ECU is already struggling with unreliable timing data, and that's your first clear warning that it's time to investigate further. Number 2. Starting issues. Having trouble starting your car, even though the engine cranks normally? This is often the next warning sign of a failing crankshaft position sensor. You might notice it takes longer to start, or the engine won't start at all, especially after sitting overnight or when the engine is hot. What's happening here is that the ECU is struggling to establish the correct ignition and fuel timing during cranking. Without a stable signal from the crankshaft position sensor, it doesn't know when to fire the injectors or spark plugs, even though the starter is turning the engine normally. Many drivers assume the problem is a weak battery, a failing starter, or a fuel issue, but the real culprit is often the ECU not receiving reliable crankshaft position data during cranking. This is your clear clue to investigate the sensor and wiring next. Number 3. Engine stalling. Does your engine suddenly die while idling, slowing down, or even while cruising at steady speeds? That's a common warning sign of a failing crankshaft position sensor. At this stage, the problem goes beyond just starting. It's affecting how the engine runs in real time. Even a brief dropout of the sensor signal makes the ECU lose track of engine speed and crankshaft position. Without that data, the ECU can't control ignition timing or fuel injection properly. To protect the engine and emission system, it may immediately cut spark or fuel, causing the engine to stall without warning. This kind of stalling usually becomes more noticeable once the engine is fully warmed up. Heat can increase internal sensor resistance or expose marginal wiring connections, making the signal loss more frequent, random, and harder to predict. If you're seeing this behavior, it's a clear clue that the ECU isn't getting reliable crankshaft position data, and it's time to inspect the sensor and wiring next. Number 4. Rough idling and misfires. Notice your engine shaking or misfiring while idling. Even if there's no obvious mechanical problem, this could be a sign that your crankshaft position sensor is sending inconsistent signals. At low engine speeds, smooth idle relies on extremely precise timing data. If the sensor signal is unstable or inaccurate, the ECU may fire the injectors or spark plugs slightly too early or too late. Even small timing errors can cause incomplete combustion in one or more cylinders, resulting in random misfires and a rough idle. Over time, these repeated misfires can increase engine wear, raise exhaust temperatures, and even damage the catalytic converter. Because the symptoms often look like worn spark plugs or failing ignition coils, rough idle from a bad crankshaft position sensor is commonly misdiagnosed, leading to unnecessary parts replacement. If you're experiencing this, it's a strong clue that the sensor or its wiring needs to be checked next. Number 5. Poor performance and hesitation. As engine speed and load increase, the problem becomes much harder to ignore. During acceleration or when climbing a hill, the engine may feel sluggish, hesitate when you press the throttle, or struggle to deliver smooth, consistent power. At this point, the issue is no longer subtle. It's affecting how the car drives. Under changing load conditions, the ECU depends on accurate crankshaft position and engine speed data to constantly adjust ignition timing and fuel delivery. When that signal is delayed or inaccurate, the ECU can't advance or retard timing correctly. The result is slow throttle response, uneven acceleration, and a noticeable loss of power, especially when the engine is under load. These performance issues often develop gradually, which is why many drivers dismiss them at first. But as the crankshaft position sensor continues to degrade, hesitation becomes more frequent, more pronounced, and starts to impact overall drivability and driver confidence. Number 6. Reduced fuel economy. As the crankshaft position sensor signal becomes less reliable, fuel economy is often the last thing to suffer, even when the engine still seems to run fine. When the ECU can no longer fully trust crankshaft position and engine speed data, it stops fine-tuning ignition timing and fuel delivery. Instead, it switches to a safer, less efficient strategy just to keep the engine running. That usually means injecting more fuel than necessary and missing optimal combustion timing. The result is poor fuel burn, higher fuel consumption, and increased emissions, without any real gain in performance. Most drivers only notice this symptom at the gas pump, not realizing it's a final warning sign that engine timing control is no longer accurate. At this point, reduced fuel economy isn't just an efficiency problem. It's a clear diagnostic signal that the ECU is compensating for unreliable crankshaft position data, making this the perfect time to move on to proper testing and confirmation. When you line up all of these symptoms, check engine light, starting problems, unexpected stalling, rough idle, loss of performance, and poor fuel economy, they all point to the same underlying issue. The ECU is no longer receiving a stable, accurate crankshaft position signal. These symptoms aren't a final answer, they're diagnostic clues. And to pinpoint the real cause, it's time to move into the actual step-by-step testing process. Now that you've seen the common symptoms as clues that the crankshaft position sensor may be failing, it's time to move into the diagnostic process. Step by step, we'll show you how to check what the ECU is seeing, inspect the sensor and wiring, and confirm whether the crankshaft position sensor is actually at fault. By following these steps, you'll be able to diagnose the problem accurately before replacing any parts. Number 1. Scan for trouble codes. The first step in diagnosing a suspected crankshaft position sensor problem is scanning the vehicle for trouble codes. You can even check codes for free at some auto parts stores. This step establishes direction, not a final diagnosis. Using any basic OBD, 2 scanner allows you to see what the ECU is detecting instead of guessing. When the crankshaft position sensor signal becomes unstable, intermittent, or disappears, the ECU can no longer reliably track crankshaft speed and position. This typically triggers fault codes such as P0335, which indicates a crankshaft position sensor circuit malfunction. In some cases, you may also see P0340, which appears when the ECU loses proper synchronization between the crankshaft and camshaft signals. However, these codes do not automatically mean the sensor itself has failed. They only confirm one thing: the ECU is not receiving a signal it can trust. That signal loss can be caused by a failing sensor, damaged wiring, poor connections, heat-related resistance changes, or even signal interference. This is why replacing the sensor based on a code alone often leads to misdiagnosis. At this point, The logical next step is to confirm whether the ECU is actually seeing engine speed in real time, which means verifying the crankshaft signal during cranking. Number 2. Check the RPM gauge while cranking. After identifying fault codes, the next step is to confirm whether the ECU is actually receiving a crankshaft position signal in real time. The simplest way to do this is by observing the RPM gauge while cranking the engine. Get inside the vehicle and crank the engine while watching the tachometer. The engine does not need to start. At this stage, you are only looking for RPM movement during cranking. If the RPM needle stays at 0, this strongly indicates that the ECU is not receiving a crankshaft position signal at all. Without this signal, the ECU cannot calculate engine speed or position, which explains conditions like a crank but no start. This points toward a failed crankshaft position sensor, an open circuit, damaged wiring, or a disconnected connector. If the RPM gauge does move, the sensor is at least producing a signal. However, this does not rule out a crankshaft position sensor problem. A weak, unstable, or intermittent signal can still cause hard starting, stalling, or misfires, especially when the engine is hot. In this case, the next diagnostic step is to visually inspect the sensor and its wiring to determine whether the problem lies with the sensor itself or with signal integrity issues such as oil contamination, heat damage, or loose connections. Number 3. Perform a visual inspection. If the RPM signal is missing, unstable, or inconsistent, the next step is to inspect the crankshaft position sensor and its wiring visually before performing any electrical tests. Locate the crankshaft position sensor. It is commonly mounted near the crankshaft pulley, harmonic balancer, or along the transmission bell housing, depending on the engine design. Carefully inspect the sensor body and wiring harness. Look for oil contamination, heat damage, cracked insulation, pinched wires, loose connectors, or corrosion at the terminals. Even a minor oil leak can soak the sensor or connector and gradually weaken or distort the signal over time. It's important to understand that many crankshaft position sensor faults are not caused by the sensor itself, but by signal loss due to wiring or connection problems. A loose connector or damaged wire can interrupt the signal just long enough to cause stalling, hard starting, or misfire symptoms. If any wiring or connector issues are found, correct them first and retest the vehicle. In some cases, restoring a clean and stable connection resolves the problem completely, without replacing the sensor. Number 4. Test sensor resistance with a multimeter. If the wiring and connectors pass visual inspection, the next step is to test the crankshaft position sensor itself electrically. Disconnect the sensor connector and set your multimeter to measure resistance. Ohms. Place the probes across the sensor's signal terminals according to the sensor type. Most magnetic, 2-wire crankshaft position sensors operate within a specific resistance range, commonly between 200 and 1000 ohms. Always verify the exact specification for your vehicle, since values can vary by manufacturer. If the resistance reading is out of range, extremely high, or shows an open circuit, the sensor can no longer generate a usable signal. This confirms an internal sensor failure, not a wiring issue. At this point, replacing the crankshaft position sensor is usually the correct solution. However, a correct resistance reading does not automatically mean the sensor is good, because a sensor can pass a static resistance test and still fail under real-world operating conditions. That's why the next step is checking the sensor's output signal while the engine is cranking. Number 5. Check sensor output voltage. If the resistance test is within specification, the diagnosis is not finished yet. A crankshaft position sensor can pass a static resistance test and still fail to generate a usable signal when the engine is cranking. Reconnect the sensor and back probe the signal and ground wires so the sensor remains connected to the ECU. Set your multimeter based on the sensor type. Use AC voltage for an inductive or magnetic crankshaft position sensor. Use DC voltage for a Hall effect crankshaft position sensor. Now crank the engine and observe the voltage reading. An inductive AC sensor should produce a fluctuating voltage during cranking, typically between 0.2 and 1.5 volts. A Hall effect sensor should produce a pulsed DC signal, switching between approximately 0.5 and 5 volts. If there is no voltage activity at all while cranking, the ECU is not receiving any usable crankshaft position data. This confirms either a failed crankshaft position sensor or a wiring or signal path fault between the sensor and the ECU. At this stage, you are no longer guessing based on symptoms or fault codes. You are directly verifying whether the ECU is receiving the signal required to control ignition and fuel timing. If a signal is present but appears weak, unstable, or inconsistent, the final confirmation step is viewing the waveform with an oscilloscope. Number 6. Oscilloscope test. For the most accurate and conclusive diagnosis, an oscilloscope is the best tool, especially on 3-wire crankshaft position sensors. Unlike a multimeter, an oscilloscope lets you see the crankshaft position signal in real time as the engine cranks. A healthy crankshaft position sensor will produce a clean, evenly spaced waveform that remains stable from one crank revolution to the next. This confirms the ECU is receiving precise timing information without interruptions. If the waveform shows missing pulses, irregular spacing, distorted patterns, or sudden dropouts, the sensor is no longer providing reliable data. These signal defects often point to internal sensor failure, heat-related breakdown, wiring resistance, or electrical interference. This step is especially important for diagnosing intermittent or heat-related faults that may not trigger a trouble code or appear during basic electrical tests. While most DIY repairs won't require an oscilloscope, this test provides final confirmation when symptoms persist, but other tests appear normal, eliminating guesswork and preventing unnecessary part replacement. Diagnosing a crankshaft position sensor doesn't have to be complicated when you approach it the right way. By starting with fault codes, confirming RPM signal during cranking, inspecting wiring, and verifying sensor output, you eliminate guesswork and avoid unnecessary parts replacement. Taking the time to diagnose the problem correctly helps you fix the real issue, restore accurate engine timing, and prevent repeat failures. And in many cases, it saves both time and money. If you found this step-by-step diagnostic guide helpful, check out our other videos covering real-world engine problems, and subscribe for more clear, no guesswork automotive diagnostics.